Page 12, very brief look at calculus. What we're going to be finding today is called antiderivatives, or integrals if it has this symbol in front of it. That little curvy S is called an integral symbol. And these are not definite integrals because it doesn't have a little number at the bottom and at the top. We'll get to that a little later, but right now it's just called an antiderivative. Sort of like a derivative, but the opposite, working backwards a little. So let's just jump in and do an example. In a derivative, you would do 2 times the front number and then minus 1 from the exponent. For an antiderivative, instead of minusing 1 from the exponent, you add 1, and that would give me 3. Now, instead of multiplying by the coefficient, you divide by the exponent. Remember, you would multiply the 2 times the coefficient. Now you divide. So what's on top there is a 3. A 3 goes on the bottom. And there's your first antiderivative. Again, that's a hidden 1 there. I'm going to add a 1 to that because it's an antiderivative. That's going to give me 3x squared. Now I take that 2 and I throw it underneath. I divide. Plus, well, that's x to the 0. That would give me x to the first. And no need to throw the 1 underneath because it's implied. And now this is a little tricky because I'm finding the antiderivative. There might have been some number over here that I took the derivative of that disappeared. So we put plus c, meaning some constant, some number. And that's the first antiderivative. I could spruce this up a little, but I'm not going to.
I'm going to find an antiderivative of 5. Basically, it's 5x to the 0, so I add 1, so that's just going to give me 5x plus some constant number c. This one here, there's a hidden 1 up there, so I add 1, so that gives me 2x squared over 2. Notice that will simplify, and that's going to render just x squared plus c. For this one, 3x to the 4th, I'm going to add 1 to that, so it's going to give me 3x to the 5th all over 5 plus c. I add some constant c, and there's the antiderivative.
Finding the antiderivative, I add 1, so that's going to give me x to the 6th, and then I divide by that exponent, 6, plus 6x, I add 1 to the hidden 1 there, so that's 6x squared, over 2, I'll be able to simplify that, plus 2x, and plus c, and now I'm just going to simplify that middle term to give me x to the 6th over 6, plus 3x squared, plus 2x, plus c, and there's that integral or antiderivative.
Now for number 6 and number 7, some people might think that they want to change that to a negative exponent, and that's very logical thinking, but in this case, the antiderivative or integral of 1 over x is actually ln of x plus c. So that's just going to equal ln, and they put absolute value around this because it's not allowed to be a negative, plus c. And that's it. I hate to say it, you kind of have to commit that one to memory. And I often make the mistake of trying to put that as a negative exponent and finding the antiderivative by adding 1 to it. And the integral of e to the x, you probably already guessed this, it was going to be e to the x, but you have to add some constant c.